So in chapter 8.3, it talked about multiplying binomials. But Logan particularly asked for a video of something harder. Where would this go? Well, all the same things apply to multiplying two quadratics. So two things with three terms instead of binomials, we're looking at two trinomials. And in doing so, you could use any of the methods. So I have one that I like the best, but if we were to distribute, we would have to take x squared and multiply it by this 2x squared minus 5x plus 10. And then take 2x and multiply it by the same thing, the 2x squared minus 5x minus plus 10. And then subtract 3 times all the same thing. And you'd wind up drawing a whole bunch of things out. It wouldn't even fit across the page. It might fit across the page, but it would be all just ridiculous to do. Now, another thing, the next part was foiling. Well, firsts, those are the firsts, the outers, the inners, and the lasts, of course, skip 2x and negative 5x entirely. So as an acronym, foil only works for binomials. You could apply the same ideas, make sure you multiply this by all three things, and this by all three things, and this by all three things, or somehow come up with some pattern if you want. Neither distribution or FOIL are particularly efficient or organized to do this. One thing you might like to do, and if you like to do this, make sure you start over on the right side of the page because it grows this way. Take the more complicated one and stack it up with the less complicated one. And the only reason I'm saying that this is more complicated is the numbers are a little bigger. You have a 2 and a 10. It's not a big deal. And then do long multiplication, basically. So negative 30, positive 15x, negative 6x squared. I'm doing the stacking method, right? So once I've done this, once I multiply the negative 3 by all this, I'm going to multiply the 2x by all this. I'm going to leave this space open. 2x times 10 is plus 20x minus 10x squared and 4x to the third. I just multiplied 2x by these three things and got these three things. And then I have to take x squared and multiply it by these things. And now instead of leaving just one space open, I'm going to leave two spaces open. And we get plus 10x squared, and we get minus 5x to the third, and we get 2x to the fourth. Now, you can see why I started on this side of the page, because it grows in this direction. Right. What's nice about this system is all of our like terms are stacked if these two things follow a pattern of being like each other. It doesn't always wind up stacked if that's not the case. And then we just add down. So we wind up with 2x to the fourth minus x to the third. These 10x's cancel, minus 6x squared plus 35x minus 30. Okay. So if we multiply two things that are a power of 2 each, we wind up with something that's the power of 4. We also wind up, in this case, we have 5 different terms. So it's a 5-term polynomial of the 4th degree. So that's one way to do it, stacking. I also want to show you how to do this with a table, which would probably be my preference. This is nicely organized. This is nicely organized. If you were to do this out, this is not nicely organized. If you just use distribution or like a foiling type concept, it's not nicely organized. Stacking is nicely organized. All right, let's try my favorite. I told you it was my favorite while we were doing the videos, and that's using a table. So I would write, it doesn't matter which one we do across the top versus down the side, doesn't really matter. So it's kind of like a tic-tac-toe board. And in each square, we're going to do the product of the thing on top and the thing on the side. So this one gets 2x to the fourth. This one is negative 5x times x squared, so negative 5x to the third. This, we're multiplying 10 times x squared, so this is plus 10x squared. Now, in this row, we're going to multiply these three things by 2x. So we get 4x to the third. We get negative 10x squared. We get 20x. Here, these three things times negative 3. Negative 6x squared, positive 15x, and negative 30. All right, now this also, if this statement and this statement kind of have the same powers, similar powers, we wind up with like terms on diagonals. All right, just like we did before. So it's easy to collect like terms here typically as well. We wind up with 2x to the fourth and minus x to the third, and the 10x's cancel, minus 6x squared, and these come together, 35x and minus 30. Hopefully it's the same that we got a minute ago. Hopefully, this is what we got a minute ago. And that looks the same. That's good. So we did it right in either way. I like this method the best. You might like this method better. But when we get into more complicated things, don't just string them all out because you wind up having a mess that you have to collect like terms with. Much better to have some sense of organization. All right, I hope that helps.